Hello everyone, here's a short video on problem solving and dimensional analysis where we will see some examples of how to how to do unit conversions.
So now in this part we're going to learn how to solve chemical problems. So in chemistry you have problems where you will use mathematical operations and equations to solve big questions. So most chemistry problems you will solve in this course are unit conversion problems, and using those units as guide you will solve problems. Solving problems is called dimensional analysis, and I'll explain that in a minute. Units should always be included in the calculation. That is important. They are multiplied, divided and cancelled like any other algebraic equation. That's what you mean by the dimensional analysis. So the general strategy for solving this is you start with the given information. So always write down what is given. The end point is to find what is the problem asking you for, or what are you finding, and then you devise a conceptual plan by using what you know or that you can look up, like for example in your some conversion factors or some equations or some formulas that you can use. So with that you will devise a plan, and the next step would be to sort information, and then you substitute and solve by following your plan, and then in the end you will double check your answer if that is making sense. Check the units, check the significant figures. That's the general steps to follow. So in dimensional analysis, a unit equation is a statement where you have two equivalent quantities. So example is 2.54 centimeters is equal to 1 inch. Now this is called as equality. This number here is called as equality, and this equality can then be used as a fraction. So you can say 1 inch has 2.54 centimeters, or you could say 2.54 centimeters have 1 inch. So this fractional form can be used as a conversion factor. So this is what we call a conversion factor. So equality and conversion factor in the fraction form, and then you can either use it in this form or in this form depending on what you want to find out. Whatever you're finding out, for example, if you're calculating some value in inches, you'll put it on top. If you're calculating something in centimeters, you'll put the centimeter on top, and I'll explain that in an example to demonstrate the same point. So most unit conversion problems take the following form. You have given information, you use the conversion factor or factors, and then you find your desired unit or what information you were looking for to begin with. So given unit times desired unit divided by the given unit. So in this case the given unit will get cancelled and you'll have your desired unit. So let's look at an example. How many inches are there in 2 feet? So what is the information that you know? You start with the given, which is 2 feet. So you write 2 feet. Then you are going to use your conversion factor. So what is the conversion factor here? I know that 1 feet has 12 inches. Okay, so my equality here is 1 feet equals 12 inches. Okay, now I'm going to express that as a fraction. So I can write 12 inches in 1 feet, because my question asked me to answer in inches, and that's the reason why I have inches on the top. So then my feet and feet units will get cancelled and I'm only left with inches. So then you multiply this 2 with 12 to get your 12 feet of answer. Now another thing was, what did I say? You have to check the units, check the correct answer, and then look at the significant figures. So here I have 1, 2, 3 significant figures. And does my answer have 3 significant figures? 1, 2, 3. So that's the correct answer. So this is how you will solve problems using dimensional analysis. There might be some problems where you will use the units raised to a power. Okay, so whenever you're building the conversion factors for units raised to the power, remember to raise both the number and the unit to the power. What do I mean by that? So look at an example where you're converting square inch to square centimeters or centimeter square. So we construct the conversion factor as follows. The first equation here, which is 2.5 centimeters is equal to 1 inch. I already know that, right, from the equality. Now it's asking me in square inches, so I'm going to square both the quantities. So the whole number raised to 2 and 1 inch raised to 2. So what happens then? So then it becomes 2.54 square centimeter square, which will be 1 square inch square. And then that's how you will use your conversion factor. So that will be my conversion factor. So this is what I meant by units raised to a power. Whenever you have problems involving the equation, solve it the same way as the problems with conversion factor. Check your 4 steps, which is sort the data, strategize, solve, and then check answer. And the equations show the relationship between the use of equation as a conversion, filling in the given quantities for the given that you have found out, and using the formula and the conversions and the given quantities, you will calculate your final answer or find out the information that you wanted to sort out. So let's look at an example. How many inches are in 8 meters? So again, the hint is start making the list. Given is 8 meters. Find is inches. And what do I know? I know that 1 meter has 100 centimeters, and I also know that 1 inch is equal to 2.54 centimeters. So then I will start writing my equation. So 8 meters is, so here I'm going to use 2 conversion factors now, right? So my first conversion factor is here, 1 meter. I've written this meter below because I want to cancel the meter unit. I want to reach the centimeter because the centimeter is my connecting factor. So from meters, I'm going to go to centimeters, and then I will go to inches. Why? Because that is how I can go from one point to the other. So I'm going to use both these equalities as my conversion factors. So meters and meters are cancelled. I have centimeters, and my next conversion factor will have inches on top because I want my answer in inches. divided by 2.54 centimeters. Centimeters get cancelled, and I have my answer. So check the answer, write the unit after your number, and then also the significant figures. So 1, 2, 3, 4, 4 sig figs, 1, 2, 3, 4. So that is check, it's correct. Another problem when I was talking to you about density, so this is what I meant. So if you have a problem where you have to solve for density, uh, where you have to find the density of a metal with the mass of 18.96 grams and volume of 4.31 cubic centimeters, I will again write down what is given, which is mass and volume, and then my equation is density is mass divided by volume, and I do that, do the calculation, and this is going to be my density, which is 4.40 grams per cubic centimeters. And remember, for division and multiplication we go with the least sig fig. So here I had 1, 2, 3 as my least sig fig, and that's why my answer is in 3 significant figures. So I have my number, answer check, units are checked, significant figures are checked. So that's how you will solve problems in this class.